we go. Okay, we are recording now.
There we go.
There we go. All right, and I got to send, and I forgot to send the, now I got to do that again. Somehow I've separated my,
It's Pendleton and HD.
there we go.
They all look
All right, y'all should be getting the screen now. Okay, exponential functions. Now, for those of you, one or two, that actually look at the videos, yesterday in 109, I covered this. So if you don't understand something, you might want to look at this video and then look at the 109. Again, let me go ahead and say this about the presentations for the first part of the unit. Is this unit 3? Unit 3. 80% will be logarithmic algebra. Everybody with me?
Yes.
Okay. 20% of the Unit 3 test will be calculator, make sure vertical, horizontal shifts, compression, things like that. Capiche? So that means that the exponentials will be calculator shift questions. So you're talking about 20 questions, you're talking about 4 from the exponentials. So for this test, the exponentials, 20%, the logarithms, 80%. So make sure you know how to do the logarithms. With that being said, here we go. All right, so exponential functions, and a lot of people say, well, I thought we went through exponential. No, we haven't. Y'all thinking of x squared. This is when you have a number raised to a power, like that. Let me just give you one. There. All right, so we need to put this in our family of graphs. Usually the basic function is 2 to the x power. That's your basic function. Let me go ahead and show you what it looks like. There it is. So I want you to draw that in your family of graphs. So that sheet that we had back in the day, back in the first unit, with the 8 graphs on it, you need to add this one to it. This is called an exponential function. The next one you're going to put is a logarithmic function, which looks almost like this one, only it's in the first quadrant because you can't take the log of a what? Negative. Good job. Okay. So, if I change this, and watch this. This is a trick I learned in the war. F of x is equal to 2 to the x plus h plus k.
Oh, I remember that from somewhere.
Yeah. Then what's the h? Horizontal shift. What is the k? The vertical shift. Well, Hubert, you're not at the origin. How do you know which point to move? You go, not by the origin now, you go by this guy. You go by the 0, 1. That's the point you move with the vertical and horizontal shift. Everybody understand? Now, you could also have this. I'm going to write this in, well, black. F of x is equal to, and I'm going to put in blue, and what would that 4 do? Press, stretch.
Not squishy, I mean.
What if I did that? It's going to go down. So all the stuff that you learned in Unit 1 is still applying with logarithms. Logarithms, same thing. I'm going to throw up a logarithm here, even though it's a logarithm's over here in the first quadrant. F of x is equal to 4 log x plus h plus k. It's going to look like that. Same thing. You're going to have a horizontal shift, and there's going to be a point on the logarithm that you move. We've been moving the origin, but now, since we don't have an origin here, since the function does not either rotate around the origin or go through the origin, we have to pick a point, and that's the point we're going to move left and right. Okay? So with these functions, there's going to be 2 or 3 examples after this. You need to be able to what? Move it left, right, compress, stretch, whatever the case may be. And if you can do that, you can handle the 4 questions on the test. Also, what comes with that? Domain and what?
Range.
So make sure you can do that. So with all that, yeah, just come on in whenever. That's fine. Yeah, just come on in whenever. Just, doesn't matter when you come in. It just come in. All right, so make sure you can graph these with your calculator. So get your calculators out and make sure you can kind of, what is it when you foretell the future? Foretell, whatever. Yes, thank you. I couldn't think of the word. What?
I said predict.
Okay, I'm sorry. Predict. Well, I don't like you, so that's fine. Predict.
That's reasonable.
All right. What? You didn't talk to me. It hurt my feelings. I feel objectified.
I'm sorry, it's fine.
Is it objectified now?
I don't know. I'm really not in the mood for a dad.
I'll just do what males are supposed to do. I'll just be quiet. How about that?
Yeah.
All right. And what is the domain? Domain is negative infinity to positive infinity. Range is from 0 to infinity. Okay, y'all having a discussion up there or what?
About this graph.
Yeah, okay, about this graph. Yeah, right. Make sure you use the table too. And I'm not going to go through the table, but there it is. All right, so what's this one going to do? Well, this one is going to be 1/2, so that means it's going to be a little bit different. Okay, it's going in this direction. 1/2, it's going in that direction. Now, again, I don't want to spend a lot of time on why does the 1/2 go in that direction, and, well, and a regular 2 goes in that direction. Well, mainly because the 1/2 is, it does, when you raise 1/2 to a power, think about what it does. What does it do? What does the denominator do? It keeps getting what?
Smaller.
Well, the whole function gets smaller, but the denominator keeps getting what? Bigger, which makes the function get smaller. That's why it has a different direction versus a number raised to a power. And that's all I'm going to tell you. You don't have to worry about anything except you have to know how to do it on the calculator. All right, so there it is. You might want to add that to your parent graphs. Why? Because you need to make the distinction in your head that when I raise 1/2 to a power, it's going to get smaller and smaller and smaller, so it's going to be in a decreasing fashion. Okay? And then after this, they should tell you to do the horizontal and vertical shifts. I'll give you another second or two. Again, what do you see that is common with this one as well as the other one? 0, 1. Because anything raised to the 0 power is what? 1. 5,000 raised to the 0 power is 1. Yes, sir.
So this is basically just 1/2 of like an x squared.
Yes.
Function.
Yes. You're basically, yeah, you're getting there. But you can't apply that if it's 1/3. Okay? Because it's going to be different. So make sure you know how to graph this. Make sure you can foretell what it's going to look like before you graph it, meaning horizontal shift, vertical shift, and all that stuff, domain and range. And make sure you can look up numbers on the table. These are all calculator drills. So when A is a whole number, it's going to be going increasing. Now you can think about that in your head. 2 to the 4th, 2 to the 5th, 2 to the 6th, 2 to the 7th. It's going to be a bigger number. Okay? Whereas a fraction, the denominator is getting bigger, so the denominator is making the function get what? Smaller. So you got to use a little bit of common sense there. Oops. Sorry. I don't know how that just happened because my hands are right here. So I don't know how it just went backwards like that. Damn Russians. There's negative 2 to the x. Now this is where you have, again, you got to separate this into two parts. Because I don't want you to say, oh, it's negative 2, that means it goes down. No, that's not right. The function is negative, so that means it goes what? The opposite direction. The 2 means what? It is compressed along the x-axis and stretched along the what? Along the y-axis. I don't like when people say, oh, that's negative 2, so that means it goes down. No, the negative in front of the function means it goes down. The 2 means it's compressed. Okay? So that's going to give you the opposite of the 2x, which is, and you see that it's a little bit skinnier because it's compressed and stretched along the x-axis or y-axis. Now, the domain is going to be the same as far as negative infinity to positive infinity because it's got arrows on it. And you can plug any number into that x, any number, whatever you want. And the range is going to be negative infinity to 0. So make sure that you can graph negative 2x on your calculator. There we go. Somebody tell me what this one's doing.
It's going to the left.
Left horizontal shift. Why? Because the 3 is connected to the what? The exponent of x. If you have a plus 4 out here, then it would be disconnected from the x. That would be the vertical shift. So this is x plus 3, and what's with the horizontal shift? It's always the opposite, so that would be left 3 spaces. So you've got the 2 to the x, so you would take the 1, 0, and you would move it 3 places to the what? Left. So it would be 3, 1. And that's what they're going to do. They'll show you that in just a second. See, there's the 1, and then you move it 1, 2, 3. Okay, what is the domain? All real numbers. What's the range? 0 to what? So you can pretty much say that any exponential function is going to have the same domain and the same what? Range. Just like your x to the first, x to the second. The domain is always going to be all real numbers. Next, they're going to give you a vertical shift. So that means you're going to move the 0, 1, 1, 2, 3. It's going to be at 0, 4 now. Why do I have that what?
A little extra. Like
What
you
extra
said,
step?
1, and then you said 1, 2, 3.
Well, remember, I told you that this point right here is what you move.
Okay, yeah. Okay, I got you. I got you, because it's not on the origin.
Yes.
Yeah. Okay.
So this is the point that you actually move. So I take 0, 1, and I move it 1, 2, 3 up. And if I need to move it left, because the next one's going to be the horizontal and a vertical shift. So let's go ahead and get to that one. Oh, no, it's not. Now we've got, okay, now, do I expect you to be able to sketch this? No. But I will tell you this, you can rewrite this as f of x is equal to 2 to the 6 to the 1/2 power. Like that. But I don't expect you to be able to do this by hand. So this is 100% calculator, so make sure you can calculate it.
Can you show us how to do it?
That's what it looks like. Huh?
Do you know how to do it without the calculator?
Well, you would have to,
Oh, Lord.
I mean, it would just be, I really don't know how you would do that. Because you're basically finding this point right here. You're finding a point right there. And that's what you're doing. So you could type in you could do this. You could do what they're doing. You could say 2. You could say 6 to the 1/2 in your calculator. And this is not graphing. They're not graphing this function. I'm sorry. That's why they didn't put the f of x in front of it. They're graphing a point. Okay? They're graphing a point. So if you have 6 to the 1/2, you're going to do 6 to the 1/2, which is this right here, 2.45. And then you're going to raise 2 to the 2.45, and that's going to give you a y, which is this right here. So the question is not graph the function. The question is graph the point.
Alright, well, that's the point, right?
That's the parent graph of 2.
To the x. Yeah. So this is not a question I would ask on a test. All right? To me, if I wanted to ask this question, this is what I would ask. I wouldn't do this. I would say f of x is equal to 2 to the x. Give me f of square root of 6. That's what I would do.
So how would I find that on the calculator?
You would just go to the table and find the 2.45.
Or can we just do that?
Yeah, you can do that. You just use the table. But I would not ask this on a test because, one, this is misleading. Okay? It would be a whole lot better if I just asked you this. Does everybody see what I'm saying?
Yep.
It's a whole lot better to ask this. So if I asked you a question like this on a test, it would be like this. It wouldn't be like that because that's kind of misleading. So not a good slide. Okay, I'm not wanting these. This is not what I want because y'all can find these on the table. I'm not worried about these. Okay, this one I am. This, write this down and you're going to need this in logarithms. All right? What do I do? Well, the first thing you do is whenever you have one like this, you need to rewrite it in terms of exponents. Well, 25 to the x, you really could solve it. You could say 5 to the second to the x power, right? Now, this is one way you can do it. There's 2 or 3 different ways you can do it. One way is to change everything to its basic base. What is 25? 5, right? 5 to the second power raised to the x power, right? And then what is 25? 5 cubed. So now I'm going to use the power rule. 5 to the 2x is equal to 5 to the third. Can somebody tell me what rule is used here? Or just kind of ad-lib it together?
The law of removing the not exponents and just having exponents.
Okay, if the bases are the same,
Yeah,
the exponents are equal.
that's what I said.
Write it down. And why do I go crazy about this function, about this? Because a lot of students are in college algebra and they don't know that rule. It's one of those rules that's not talked about a lot. Anybody want to volunteer that they didn't know that? Okay. All right. This is one of those rules that falls through the cracks. If you have 2 bases that are equal, you can set the exponents equal to what? Each other. So that would be 2x 2x is equal to 3. X is equal to what? 2/3. So you could rewrite that as 25.
Is it 3 halves?
3 halves, thank you. 25 to the 3 halves is equal to 125.
Yay.
Now, that gives us that exponential rule. If you look on your exponential rules from yesterday, the one on the bottom says you can write a radical as an exponent. This is exponent over index. So let's check it. We're going to check it now. What's the index? The index is what's in front of the what? The radical, right? So that's the square root of 25 raised to the 3rd power is equal to 125. So that, if you follow that last rule of the exponential laws that you should remember, that's the exponent. And that's the index. So that's the square root of 25. What's the square root of 25?
5.
And what's 5 to the third power? 125. So it does.
Sense, boy. That's something.
And I guarantee you, there's somebody that has never seen that rule before, or they forgot it. And that's this rule right here. If you have the same base, you can set the exponents equal to each other.
Makes sense. Can you give us another one right there, though?
Another one?
Are we gonna get one?
There's going to be some in the homework. Don't worry.
Oh, okay.
You could make one up, but you just have to know your cubes. You could say, I'm trying to think of one, maybe 16 to the x power is equal to 64, something like that. 16 to the x power, I hope it works. 16 to the x power is equal to 64. And what's the base of 16? So that's 4 to the second power raised to the x power is equal to 4 to the what? And works the same way.
That makes sense. Gotcha.
Will you be tested on this in the graphing section or the algebraic section? Algebraic. So you're going to see at least 2 to 3 of these on the
No, we
test.
need like 5 of those.
Okay, yeah.
I'll pass that.
I guarantee you I could fix it up and you would not know what to do.
Don't do that.
With some decimals or some fractions or...
Oh,
You
yeah.
can get a
That way,
625.
Oh yeah, I forgot. That would be raising the bar. We don't want to raise the bar.
I mean, if you do it in class, then I'll be fine.
We want to... You sound like my son. Daddy, if I'd make an A if you were sitting beside me. And they're going through it, and they should get 3 halves. And we feel good about ourselves.
Sorry, Kyle.
There you go. Look at there.
Okay, let's wait. It's like 3 seconds to do this. And we're supposed to have it.
There you go.
Hey, you should be done already.
What the heck?
I'm giving y'all a hint,
Okay,
Oh,
that's
that's
all.
it.
because this one is the one that really freaks people out. Because if you reverse, and there's a rule, if you flip what's inside the parentheses, it makes the sign of the exponent the opposite sign. It's kind of a continuation of the inverse rule. The inverse rule says, I'll show you the two I'm talking about. The inverse rule says if I have 1 over x to the negative n, then I can what? Take it upstairs, I can flip it, it becomes x to the n over what? 1. Now that's one inverse rule. The other inverse rule is called the inverse power rule. And the inverse power rule says that if you have parentheses, which is different from this, and I have x to the n over x to the m, or y, I'm sorry, so they're different bases, I can flip them, or to the negative w power, and I can flip them y to the m over x to the n, and that becomes a positive. They're 2 different animals, okay? One's a cat, one's a tiger, okay? They're same kind of species maybe, but they're not the same animal. This is parentheses. This is a quantity squared. This is just one term squared. It's different. Now, after you distribute this with the power rule, then you could flip, and it would be like this right here. But you don't have to worry about it when it's parentheses. So with this one, I flipped it, or they flipped it, and you get 3 over 1 raised to the what? Negative x power, which is this right here. Okay? Now, I did 3 to the negative 1. That comes up, that's 3 to, and that's where they get 3 to the negative x, just like that right there. Okay, I skipped a step. Is equal to 3 to the 4th, so x is equal to negative what?
4.
And if you plug negative 4 into this, flip it, it would become positive 4. And what's 3 to the 4th power? 81. So there's another test question right there. Should you be able to do these without even faltering? Yes, because logarithms, you're going to be doing this. Okay, how much is left out of the 20-minute class?
20 minutes.
You kidding?
No, he's right.
20 minutes? Did I guess that right? Wow.
Yes.
See, x is equal to negative 4.
Bring on the decimals.
Yep.
Oh, okay.
Yeah, I would quit.
Take it back.
What did I tell you about fractions? Whenever you can, try to get rid of them. I don't know if you're going to be able to get rid of these as easy, but I'll just go ahead and give you a hint.
Just let us read real quick. This is what you wrote down. That did nothing.
How about the next one? There we go.
Okay.
I guess you're ahead.
Y'all settle down, Oconee. Pendleton, settle down, please. Oh, you won't believe this, but some of the Pendleton Math 111 students are going to come to Anderson. I couldn't believe it.
Oh my God.
I don't know. They just said they wanted to come to Anderson.
See you. They made a run.
Don't get a grandson.
You know what happened?
kidding,
You know
I'm
those that said they wanted to come to Anderson, they probably got beat up when they went outside in the hallway. Pendleton not supposed to talk to anybody. My friend of mine works in the lobby down here. She went to Pendleton the other day. She said, "You know what? It's like a prison up there. Everybody walks through the hallways. They don't talk to each other. It's kind of like, you ever seen the movies where everybody's walking in their chains and they're walking like this through the prison?" Well, that's what said Pendleton felt like. Is it that way at Oconee?
Mm-mm.
I bet everybody talks to everybody, don't they?
Yeah.
But at Pendleton, it's like you walk down the hall and you just look forward. If you look at anybody that's scared, you're going to slap.
Mr. Huber, you should go to
I should go to the what?
all of my classes are there. I have classes that are
I taught at Pendleton. I taught at Pendleton for 15 years. My office was on the second floor of Oconee. You know, the end that doesn't have a elevator? It was right in front of the stairwell, right there. There's 2 offices there. Mine was on the left. That's where I was for 15 years. And then my boss said, "You want to go to Anderson?" I said, "Do I need to go to Anderson?" And I said, "Would it help me to go to Anderson?" And she said, "Yes." And I said, "Why?" She said, "Because that's where you're from, and as you get older, you're going to hate people." And I said, "Yeah, pretty much." And
your boss does that?
yeah, because she knows me. She's known me for 20 years.
She's a boss.
Yeah. That was a long time ago. She's retired now. She was a good lady. And you know what? It was the best decision she ever made for me. She said, "You're going to Anderson." Well, at that time, they had a teacher here, and for every 30 students that took a class, 2 would make it. It was awful. And they couldn't start the Anderson campus with a math teacher that was only passing 2 out of 30 students. So that's why they sent me here. It's been pretty good to me. There's no cardiac heel. There's no parking problem. People talk to each other and communicate with each other, Pendleton.
Yeah.
And it's kind of like it's more like a little family here. So
Yeah,
it's not like Pendleton Prison.
Yeah.
This is Pendleton.
Can they see you?
Yeah, they can see me. See, what the heck do you think that Contraction is right there.
Over here and then
Oh, it's all about you. Is that what you thought?
No, that's not
Oh, okay.
what
Can y'all see her? Let's make it
No,
all about
that's
her.
not
Let's
We
make it
can
all
see,
about
we can see
her.
everyone.
No, I was saying, I thought it just did like this.
No, it's just all about
And then
you. It's
you-
just.
Hey, calm down, sir.
There it is.
All right. So look what they did. Do y'all know where I would say, okay, what's 3 divided by 2? And y'all would say 1.5. Okay? No, it's 3 halves. Well, now y'all can change the 1.5 into a what? A fraction. And it makes things a whole lot better.
What? Go ahead. Okay.
See? Ain't that nice?
Yeah,
Yes.
it's beautiful.
And you
You got
change
15 minutes.
the cube root, thank you. The cube root of 27
Dance.
and the cube root of 8 is 3 over 2, so now we get 3 halves
Is it always gonna be like that?
to the x plus 1 is equal to 3 halves to the what?
That was hard.
So x plus 1 is equal to 3x. I bring the x across the river. 2x is equal to 1. Dang old 1/2. I told y'all about Dr. Harden, didn't I?
No.
Who's here?
My first calculus teacher at Clem's on. He's about this tall, and he had silver hair. In fact, if you go to Clem's on, the bottom of Martin Hall, the O building, he's got a plaque beside his little office because he died. He was 107, and he was still teaching.
gosh.
And they had a little plaque beside him and had a little picture of him. He's about this tall, and he grunted. And when he drew a little arrow like this, you know how to do this. So in calculus, what do they assume in calculus? They assume that you know all the algebra there is to know. So he would just start up here and he would say, you know how to do it. That's the way he taught. So whenever I do that, I do that.
You're like a little like Danny Baby.
No, he had white hair. He had a lot of hair on his head, but he's about this tall. Hardened. I would assume that's some kind of German. I would assume he's German or some back because he was very abrasive, very. And then I had Dr. Ruckel. Dr. Ruckel played in his office all the time, Tetris. He was.
Did you like him?
Yeah, he was all right. He taught advanced calculus 1 and 2, and he would do first, second, third derivatives just off the top of his head, where it'd take us like a half page to do one derivative. It was amazing. Very smart man.
What level did he get to in Texas?
I don't know. But if you walked in on him and didn't knock, he would get mad because if you just said, Dr. Harden, he would jump out of his chair because his back faced him. He'd been there playing Tetris. There you go. And they said graph it. So I'm not really worried about you graphing it. You can graph 1.5 x to the first minus 27, and that's the way you graph it. I'm not really worried about graphing this. I want you to be able to solve it algebraically. That's what I want you to do. And they're showing you how to graph these, and I'm not really concerned about that. You just have to bring everything over on one side and type it in. The only thing you have to make sure of when you're graphing is put parentheses, and maybe parentheses like that. You might want to play around with graphing them, but you got to know how to graph them because your calculator, even though some of y'all think it is a living, walking being, it is not. You have to tell it what to do, and putting parentheses around these kind of helps. Okay? All right, try that one.
Okay, cool.
This is another test question. Y'all drunk.
I'm just saying, okay, what is 3?
You bad rebel kid.
Okay.
Yeah, you might as well just quit.
I can't do it. What?
Because 81 is just 3 cubed, and then it's 2.
Oh wait, it's greater than.
Oh my God, y'all are actually thinking. Y'all are not supposed to think, you're supposed to quit. God, why do y'all want to raise the bar? Don't y'all know that math is racist?
Oh yeah, that's right, math. I want to be racist.
So 3 to the 2x is equal to 3 to the what? I'm sorry, less than. Less than 3 to the what?
4.
3 to the 4th. So 2x is less than 3 to the 4, sorry. And x is less than. Now, what did I always tell you to do when you had an inequality? Always what? Graph it. This is negative infinity. And this is positive infinity. What numbers are less than 2?
1, 0, or negative.
What?
Everything below 1. 1, 0, negative.
Well, yeah, you got to put what kind of circle here?
Open.
Open, which means that this is negative infinity to 2 with a parenthesis. So there's your interval notation. So that's your answer. Or you can say x such that, and then put your answer here. X is less than 2, and then braces. Analytically is another word for algebraically.
Such that. Yeah, that would be such that.
Yeah, you can impress your friends at the bar by using such that.
that.
Remember that? Oh God, y'all may not remember this. Do you remember the Miss America? I think she was from South Carolina. Yeah, such that Iraq and such that.
Well, some people in our wonderful nation do not have maps, and
Yeah.
they will not know about the Iraq and
Such
South
that, and
Africa.
such that, and such as, and she was a
That was the funniest
dumb
thing.
boy. Have y'all ever seen that?
Yeah.
We should play it right now.
Hey, Jack.
I don't want
You don't like what?
I don't watch.
You don't like what?
I don't watch.
Yeah, I don't.
I don't watch pageants.
I don't either.
Yeah, I just.
The only reason, if
It's
you
not
ever
my thing.
watched her, is she's on YouTube. I mean, that girl has been plagued as one of the dumbest people in America. I wonder how she's doing now.
Such that.
Look at there.
She's getting money off of you.
How much?
Way too much work.
Okay, how much?
I got this.
How much? 9 minutes. Let's finish this one.
Wait.
America, such that Iraq, and such that.
It made no sense. Except.
Well, I tell you, if you want to shut down anybody, ask them a political question. It'll shut them down faster than anything because they don't know. You need to change it.
I was like, listen, I live in America.
You need to change it. You need to be more aware of what's going on. Actually, we're a
We're
republic.
not a democracy.
We're a republic.
On the left here.
Yeah.
Our president is. Anyway. And yeah.
Okay, what's wrong with Trump? Do you want what?
Build a wall.
Do you have a door in your house? Do you lock it? You're racist. Why don't you let everybody?
Because of the house.
Okay, then why don't you want a wall over the country?
Okay, then everybody should put a wall in their country.
Everybody does.
Okay, then let's get a wall, guys.
See, that's what I'm saying. People don't know. You try to go into Mexico, and no, nobody wants to go to Mexico. Try to go into Canada and not get
Why can't
legal
we just all get
citizenship.
along?
See what happens.
We lock our doors because people might come in and shoot us up.
Why does Six Flags have a fence around their amusement park?
Zombies.
Oh, crazy.
Erase.
And you want an open border?
Okay.
Why does Disney World have a wall around their amusement park?
Zombies.
Zombies
Ever
have
seen
problems.
Zombieland?
They're racist.
They're racist, exactly. There you go.
Just people who gonna try to kill me, I have a problem with this.
No, it's X.
Well, how you gonna keep 'em out?
Six.
I'm just playing.
Did y'all hear that?
Yeah, he's racist.
I want you to do that again. What are you doing?
I just quit.
You know what she did?
I'm just kidding.
What is this? What is that? You know, I could throw you out of here for that.
For real?
She just shot a gun.
No, I didn't.
Did y'all see that?
Oh, I'm sorry.
She's a terrorist.
I'm not. Oh, you
Oh my
did it
God.
too? Well, I guess
It was
you were one of them.
Well, I'm already a terrorist anyway.
Terry.
All right, what do we do here?
Terrorist.
How about 1/2? Oh my goodness, look at that.
X.
I like that.
Negative.
1/2. Can y'all see this better? Put on to me. Okay.
Yes.
Less than 1 over what? 2 raised to the 4th raised to the x plus 3.
Okay, you lost me.
Because he flipped it.
Yeah,
Where do you
you flipped
get
it.
negative?
You didn't flip it.
You didn't flip it. Be quiet.
Yeah.
All right. No, you would flip it if this was 2 to the 4th power. You would flip it like that. Okay. So 1/2.
Well, what the heck happened to your marker?
It's on a highlighter.
Okay.
This is better. We like this better.
Yeah, we'll change it probably after everybody gets tired of it.
I put it on that one.
Less than 1/2 raised to the 4 times x plus 3. And now, of course, negative 2x is equal to what?
Where I was like,
4 times x plus 3. So negative 2x is less than 4x plus what? 12. Bring the 2x across the river, and that's going to be 6x
Terrence has a
minus 12. What?
Where'd this negative 2x come from?
yeah, it's positive to it.
Oh, sorry. I don't know why I wrote that.
Oh, dang.
Thank you. So that's going to be, hold on. That's going to be negative, that's going to be 2x, and then negative 12 divided by 2. So x is greater than negative 6.
Thank you, but she starts screaming at the
What?
Wait, but when you divide by
Yeah.
the negative, wouldn't it?
I don't teach that way.
Okay.
I keep variable what?
On the good one.
I keep the variable positive.
Oh, I did the right thing anyway. Yay.
So, as you can see, you've just got 4 or 5 questions, and those will be your first set of questions on the test as far as algebraic. And they get negative 6. X is less than negative 6. X is less than is greater than negative 6. X is greater than negative 6. All right, we'll worry about that later. I don't know why. Where did I mess up? X is greater than negative 6. Okay. Oh, wait a minute. Okay. All right, I'm going to get rid of the highlighter and I'm going to redo it. Hold on. I'm going to redo this. I don't understand why I'm getting a different answer.
Was the answer X?
All right, y'all got to be quiet for a minute because I want to find out where this problem is. 1/2 raised to the 2x is less than 1/2 raised to the x plus 3. 1/2 to the 2x less than 1/2 4. Please. Are y'all finished? 4
Not yet.
plus 3. Stand when people do that. It's so rude. 2x is less than 4x plus 12. Bring the 2 over, and that's going to be 2x. Bring the 12 over, and that's going to be negative 12. Divide by 2, divide by 2. X is greater than negative 6. So that's the answer. I don't care what they say. Plug in, what's greater than negative 6? Negative 5? So negative 5, 2 times negative 5 is what? 10? Negative 10?
Yeah.
And negative 5 plus 3 is what? Negative 2? Correct?
Yep.
All right, so 10, if I want this positive, I'd flip this, right? So that's going to be 20, right? I'm sorry, 2 to the what? 2 to the 10th power is less than, and if I want to flip this, I'm going to flip this to 16. 16 to the what?
I don't remember.
Second power, right? Well, that's wrong. Okay, something's wrong here. I don't know something is wrong, because they're getting less than, and I'm getting greater than.
I got greater than.
Wait, I don't even remember.
You should get the same answer no matter how you do it. Okay, I've got let me see what they're doing here. And they're,
I know it's.
no, it doesn't matter whether you have a positive or a negative. If you keep your variable positive, it should be the same. Let's see, look here. They flipped it right there.
They shouldn't.
They shouldn't flip it.
Why did they do that?
I have no earthly idea.
They equal.
Okay, I've got to see why they're doing this. I've never seen that before. I've never seen flipping before you get a negative or a positive exponent. Okay, we'll take it up from here. Write down, we'll take it up from here. I've got to figure this out. I will see y'all. Have a good weekend. See y'all Monday. Work on 6.1, 6.2. See y'all. Yeah, we don't have school Tuesday because we got to waste a day. Faculty, staff got to go up Pendleton and look at something for all day and waste all day.
Can we exit out?
So, we don't have class Tuesday. No classes Tuesday.
Not even a lab? No lab?
Yeah, we don't have a class.
Okay, cool.
Yeah, it's a joke. I don't even want to talk about it.
it.
I'm talking a waste of time.
No, because it's 54. How are the,